Good morning, grade 11s. Welcome to Wednesday morning, May the 20th. I hope you were able to enjoy your long weekend. It's the first video since then, and I hope that you have all seen your test now and are beginning on writing it if you haven't already finished it. I encourage you to keep working on it. Again, you have until Friday to hand that test in. Before we get going on what we're going to talk about today, I want to share with you our verse of the day. It comes from Isaiah 26 verse 3, where it says, "You will be kept in perfect peace, those whose minds are steadfast, because they trust in you." So again, just a reminder to trust in the Lord, and He will provide you with a perfect peace. And you can be encouraged and encourage one another with that today. All right, today we want to start the next section of our unit on waves, and we are going to move into light. So with both sound and light, those senses allow us to perceive the world around us, and so we want to continue perceiving, and this time with light. And what you're going to do is you're going to actually do a lot of reading, not a lot, 4 pages out of your textbook you're going to read as your assignment today, looking at some properties of light, some properties of what's called illuminance and luminous, what's an illuminated source versus a luminous source, and words like opaque and transparent and translucent, all words that you've probably heard before, but we want to make sure we have the physics definition of them as we move forward. And so that's really all your assignment is going to be, is to do that. But as we get into light, we do want to talk a little bit about some history of light. So when we go back and look at light, light behaves oddly, for lack of a better word. It can be seen as 2 different things, and there's been a debate throughout history about what exactly light is. And the debate rages between, is light a stream of particles, little packets of energy that's emitted from a source, or is light in fact a wave? And so we have scientists like Pythagoras who believed it was a stream of particles. And we have Aristotle disagreed with Pythagoras. They lived around the same time, and he believed that light was a wave. Moving forward, Isaac Newton believed that light was a stream of particles. And another scientist by the name of Christian Huygens believed they were waves. Huygens did a lot of work with light, and that's why he's listed in this list as somebody you probably haven't heard of as a scientist. These other 3 you probably have heard of. But what it came down to as history went on, as technology increased, what it comes down to is light is actually both. It can be a particle, it can be a wave. And the reality is, if you're doing experiments and you want to show that light is a particle, light will show as a particle. If you're doing experiments and you want to show that light is a wave, well, then your experiments will show that light is a wave. So depending on what you're looking for, that is what you will find when it comes to light. So it is both. It is a wave and a particle. We are going to look at the wave aspect of it, just because we're in our waves unit. And so as you do your reading, you're going to be reading some pages out of your textbook. And again, it's going to talk a little bit about what light is. Okay? It's going to talk about luminous versus illuminated sources, and those other words that we talked about. And it's also going to talk about being able to illuminate something. How do we light a room, per se? All right, and you're going to do the reading on it today, and then tomorrow we're going to talk about the formula for it. And so tomorrow we're going to come back and we'll talk about the formula, and we'll be able to do some questions about light output and illuminating the surfaces around us. And then we'll get into a few more aspects of light and how it behaves as a wave. And just so you know where we're headed, we're going to be looking at properties of reflection and refraction. We're going to look at mirrors, and we're going to look at lenses, and how that all plays together with light and those properties of waves that we've already studied in the past. So that's where we're going to go. That's all I want to give you today. So you can find the page numbers to read on Connect alongside with this video. And we'll be back tomorrow to talk a little bit about the equation for how illuminance works. And then we'll move forward from there. So continue to work on your test if you haven't already finished it. Do the reading that is assigned, and we will see you tomorrow.